So this video is about kinetic friction. Kinetic friction happens only when an object is moving with respect to a surface. So if you have an object sitting on a surface and the object's already moving, if the object is not moving, then the only source of friction that you're going to consider is static friction. When the object is moving, then you can also consider kinetic friction. So kinetic friction, just like static friction, has the same relationship. I can say the kinetic friction, Fk, is equal to the coefficient of kinetic friction times the normal force. So the equation looks the same. The only issue is the object has to be moving. So if the object's moving and it has kinetic friction, a kinetic friction coefficient, then there will be kinetic friction acting on it. So it's not like static friction where there's a threshold. Kinetic friction is going to always be there if the object's moving and if there is a kinetic friction coefficient. Alright, so if you're pulling on or pushing on the object with a force F here, then you're going to have kinetic friction that's going to be resisting that force, and it manifests itself as another force. So if the object is moving at v constant, that's a special case for the kinetic friction. If the speed is constant of this object, I'll show speed to be the double arrowed vector there, then I could say then the two forces cancel. And there is no net force acting on the object. So in that case, the kinetic friction force is equal to the force that you're pulling on the object. So if you wanted to relate this to the kinetic coefficient of friction, you could say, well, the force I'm pulling on the object, therefore, has to be equal to the coefficient of kinetic friction times the normal force. If you know the weight of the object, you know the normal force. And you can solve for the kinetic coefficient of friction in that case. If the object is moving with a velocity that's not constant, but that's increasing, that means that the object has an acceleration. So I'll put my two forces here. Of course, I have Fn and Fg, and I did on the last slide as well. But if the force that you're pulling the object is greater than the kinetic friction force, then object will accelerate. It won't accelerate as quickly as if there were no friction, but it will accelerate in this case. And how big is the acceleration? New slide for that. The size of the acceleration, I'll write in here, I'll write Newton's second law, F net equals ma. F net is equal to the force that you're pulling on the object minus the force due to the kinetic friction. That's equal to the object's mass times its acceleration. So this is whatever force you happen to be pulling. This is equal to mu k Fn. So that means that the acceleration is equal to the force you're pulling the object minus the force due to kinetic friction. I should have substituted, but divided by the mass, which is equal to F minus mu k Fn divided by the mass. That's the relationship between the force, between the acceleration of the object, the force at which you're pulling the object, which is that F right there, the kinetic coefficient of friction, the normal force acting on the object, and the mass of the object. Now typically the normal force is equal to the weight of the object, which is equal to mg, if the object's on a flat surface. And if the object doesn't have any weight resting on it, then this relationship is true. So there's a number of ways that you can relate all of these quantities, but hopefully this gives you a little bit of a review of the concept of kinetic friction.